Welcome back to the channel. Today we are talking about one of the most spiritually charged, logistically complex, and architecturally breathtaking airport projects ever attempted in the history of modern construction. This is Madinah Airport, Prince Mohammed bin Abdulaziz International Airport, the gateway to the second holiest city on Earth. This is not just an airport. It is not just concrete and steel and glass arranged in a field of Saudi Arabian desert. It is a structure built to receive millions of human beings who have saved their entire lives for a single journey. It is a threshold, a doorway between the ordinary world and the sacred. And building it required an act of engineering ambition that the world had never seen in this context. Imagine the full weight of what they faced. Temperatures that can climb past 50 degrees Celsius on the tarmac, a desert environment with blinding dust, brutal sun, and air so dry it cracks metal seals and warps materials. A city considered so sacred that non-Muslims cannot even enter it. An airport that had been operating since the 1950s, still functioning, still receiving flights, needing to stay open while a brand new terminal was constructed right beside it. Peak passenger surges during Hajj season, when millions of pilgrims descend in a matter of weeks. A location with almost no local industrial infrastructure to support a project of this scale. A workforce drawn from multiple countries speaking dozens of languages. A $1.2 billion budget governed by Islamic financing principles. A construction timeline measured in years, not decades, because the faithful could not wait. And they decided to build a world-class international airport terminal, from scratch, in the middle of one of the most demanding places on Earth. Before we continue, make sure you subscribe to the channel so you never miss another video like this one. And stay with us until the end, because the story of how they actually assembled the roof of this building, upside down, is something most engineers still can't believe. At first, there was only an old airport. Aging runways, an outdated terminal from a different era, facilities that were simply not built for the scale of what Madinah was becoming. No passenger experience worthy of this city. No infrastructure for the millions who were coming. No space for the jets, the baggage systems, the immigration halls, the prayer rooms, the movement of enormous human crowds. Just asphalt, desert, and the outline of a vision that had not yet taken shape. If you simply expanded the old terminal, you would be layering a modern system onto a crumbling foundation. The old building could not carry the structural loads. It could not accept the mechanical systems, the air conditioning demands, the electrical capacity needed for a 21st century operation in extreme heat. If you relocated the entire airport to a different site, you would shut down the only air gateway to one of the most important cities in the world during construction, stranding millions of pilgrims with nowhere to land. And if you built a conventional steel and glass box, the kind of airport terminal you find in 100 other cities, you would place something cold and generic in a city that deserves something that understands what it means. None of these approaches were acceptable. None of them were worthy. And so a different answer was required. The solution was not a renovation. It was not a patch job. It was the construction of an entirely new terminal complex. 156,000 square meters, built on the opposite end of the existing runway from the old terminal, so flights could continue uninterrupted while the new building rose from the ground. And the structure that rose from that ground would not look like any airport terminal ever built before. So where do you begin when the project is this enormous, this complicated, and this sacred? You begin with the ground itself. Before a single column goes up, before a single steel beam is cut, a project of this scale needs to understand what lies beneath its feet. Geotechnical teams moved across the site. They drilled boreholes into the desert earth. They analyzed soil composition, bearing capacity, groundwater levels, seismic behavior, the stability of the ground across 400 hectares of terrain. Every number mattered. Every meter mattered. Because you cannot place a building designed to hold thousands of people on ground you do not understand. The soil surveys informed the foundation design. They told the engineers how deep the piles needed to go. They told the structural teams how much load the earth could bear before it started to move. They told the planners where the drainage needed to be engineered, where the water from rare but intense desert rains would flow, and where it needed to go. This was not glamorous work. It was invisible, silent, unglamorous, and it was the work that made everything else possible. Then came the site preparation. And this was work of its own kind of scale. Hundreds of hectares of desert needed to be cleared, graded, and leveled. The existing airport had to remain operational throughout. Every heavy vehicle, every excavator, every earth-moving machine had to be coordinated so its work zone never threatened an active taxiway or runway. Workers from Turkey, the Philippines, India, Pakistan, and Saudi Arabia began arriving on site. At peak construction, 5,000 people were working simultaneously. The dust was constant, the heat was relentless, and every single one of those workers needed to be managed, housed, fed, and kept safe, in a location with almost no surrounding industrial support. Site management teams posted notices in 5 languages. They used pictograms when words could not cross language barriers fast enough. Safety became a culture, not a requirement. And across 22.8 million hours of work, there were 0 fatalities. 0. That number alone deserves a moment of silence. Then came the foundations. Deep, reinforced concrete piles driven into the desert earth. Pile caps connecting them. Ground beams tying the whole system together. Thousands of cubic meters of concrete poured in controlled conditions because concrete behaves differently in extreme heat. It cures faster, it cracks differently, it loses water too quickly in dry desert air. Curing agents were applied. Shade structures were erected over fresh concrete to slow evaporation. Every pour was timed. Every batch was tested. The reinforced concrete substructure had to handle not just the weight of the building above, but the vibration of aircraft engines nearby, the occasional tremor of seismic activity, and the thermal expansion and contraction of a structure exposed to massive daily temperature swings between the desert night and the desert noon. Then came the decision that changed everything. The design of the terminal was inspired by the palm tree, not as decoration, not as a mural on a wall, as the actual structural system of the building itself. The architects at Scott Brown Rig looked at the palm frond, the way it radiates, the way it branches, the way it spreads a canopy from a single trunk with the minimum possible material. And they saw an engineering solution. A structural column shaped like a steel palm tree could support a massive roof area by spreading the load outward from a central point, just as a real tree spreads its weight from trunk to branch to frond. You could cover an enormous floor area with fewer columns. You could create a light-filled, open, soaring interior without a forest of supports blocking the space. You could use less steel, less material overall, while achieving more structural performance. And you could do something no generic airport box could ever do. You could make a building that felt like it belonged here. But the engineering of those palm columns was not simple. Each one was fabricated from structural steel. Each one had a specific geometry, a trunk that flared outward into branching steel arms, radiating in patterns drawn from Islamic geometric principles. The grand canopy roof above followed an octagonal family of radiating, intersecting, and concentric lines that resonated with centuries of Islamic architectural tradition. Every component was calculated. Every joint was analyzed under computer simulation. The roof was designed as a kit of parts, manufactured off-site, transported to the desert, assembled on-site, and lifted into place using mobile cranes. And here is where it gets extraordinary. Each palm tree column was built upside down, at ground level. The workers assembled the branching steel crown of the column first, while it lay flat on the ground, pointed downward. Then the trunk was attached. Then the whole structure was rotated, lifted by cranes, turned through the air, and set upright into its final position. They built trees upside down in the desert and then stood them up to hold the sky. 11,550 tons of structural steel went into the new terminal. 11,000 tons of steel, shaped into palm trees, shipped to a city in the interior of Saudi Arabia, and assembled by 5,000 workers in the heat. Each phase of the column lifting required intricate computer analysis to verify how the assembled steel would behave during rotation. The engineers had to model not just the finished column, but the column in motion. As a crane picked it up, as it rotated, as it swung through the air and settled into its bearing. Every angle mattered. Every weld mattered. Every calculation mattered. Then came the roof itself. The grand canopy spread across the terminal's interior, filtering light through a geometry of steel and glass that references Islamic pattern-making traditions going back 1,000 years. The roof structure was engineered to manage solar heat gain, because in Medina, the sun is not just light, it is force. Thermal modeling told the engineers how heat would move through the roof on a July afternoon. Glazing specifications were chosen not just for beauty, but for their ability to reduce the heat load on the cooling systems below. Without getting that right, the air conditioning systems would be overwhelmed. With it, the terminal could breathe. Then came the secondary systems, and calling them secondary does not mean they were less important. The air conditioning system in a 156,000 square meter terminal in the Arabian Peninsula is not a secondary concern. It is a life safety system. The cooling load in Medina during peak summer can exceed anything a standard airport faces. Chillers, air handling units, ductwork, and controls had to be sized for a building that might receive tens of thousands of passengers on a single Hajj day, in temperatures that approach 50 degrees outside. The baggage handling system was designed to move thousands of bags per hour. The luggage of pilgrims who have traveled from Indonesia, Nigeria, Pakistan, Morocco, Turkey, Bangladesh, and 100 other countries, each carrying the belongings of a lifetime journey. The system needed to be fast, reliable, and gentle, because many of these bags contain items of deep personal and religious significance. The electrical infrastructure was built to match. Substations, distribution boards, backup generators, uninterruptible power supplies for critical systems. A power failure in any ordinary airport is an inconvenience. A power failure in Medina during Hajj season is something that cannot happen. Redundancy was not optional. Every critical system had a backup. Every backup had a backup. Then came the fire systems. Sprinklers, detection heads, suppression systems in mechanical rooms, evacuation notification systems calibrated for a building full of passengers who may speak no common language. Then came the data and communications infrastructure. The fiber optic backbone, the check-in system servers, the flight information display network, the security screening technology, the biometric processing systems, the immigration control equipment. A mosque was built as part of the terminal complex. Because this is Medina, prayer is not an afterthought. It is as essential as the runway. 6 air-conditioned pavilions with tensile fabric roofs were constructed alongside the terminal to handle the extreme passenger peaks of Hajj season, when the volume of arrivals compresses the whole world into a few weeks. These pavilions covered thousands of square meters with fabric structures designed to provide shade and cooling in the open air, a textile engineering challenge of its own. Multiple types of fabric roof were designed and installed. The Hajj pavilion roof, the baggage hall roof, the mosque courtyard palm canopy, the walkway shading vault, the bus stop canopies, the car park shade structures. Each one engineered for desert wind loads, extreme UV exposure, sand abrasion, and decades of service without failure. 26 ancillary buildings were constructed as part of the first phase. Ground support equipment facilities, fuel systems, fire stations, cargo buildings, airside vehicle maintenance areas, catering facilities, utilities plants. 10 kilometers of new taxiways were laid, connecting the terminal to the runways. The runways themselves were expanded and modernized to accept wide-body aircraft. The Airbus A380s and Boeing 777s that now bring pilgrims from across the world. New apron areas were paved for 16 aircraft parking stands. Airfield lighting, instrument landing systems, radar installations, navigational aids, pavement markings. Every element of the airside had to meet international aviation standards. Then came the interior. And the interior of Medina Airport is not a generic departure lounge. The check-in hall, the immigration and customs zones, the security screening areas, the departure gates, the arrivals hall. Each space was designed with Islamic geometric patterns, calligraphy, and materials that evoke the culture and spirit of the Hijaz region. Marble flooring, high ceilings that breathe, natural light filtered through the palm canopy above, quiet zones where pilgrims can rest or pray between flights. The terminal speaks to the people it serves. Then came testing. Every system individually checked, verified, and certified. The baggage system was run empty, then with weighted bags, then at full simulated load. The air conditioning was activated in sections and its performance measured against design specifications. Every fire detector was triggered. Every emergency exit was tested. Every escalator, every elevator, every automated door, every boarding bridge, every piece of ground support equipment was put through its paces before a single passenger walked through the door. Test operations began in April 2015. The first real flight, a Saudi domestic service from Riyadh, landed on April 12, 2015 at 11 in the morning. The first departure followed 45 minutes later. The project was officially inaugurated by King Salman in July of that year. And before that year was out, it had been named the world's best airport development at the Engineering News Record's Global Best Projects competition. It was also the first commercial airport terminal in the entire Middle East and North Africa to receive LEED Gold certification, a recognition that a building built for this kind of scale in this kind of climate could still meet the highest standards of environmental responsibility. Most pilgrims who land at Madinah Airport see a beautiful terminal with soaring ceilings and columns that look like trees. They do not see 11,000 tons of steel assembled in the desert sun. They do not see the palm columns built upside down on the ground and rotated upright by cranes. They do not see the 22 million hours of labor that shaped every surface they touch. They do not see the geotechnical reports, the computer simulations of steel in motion, the 5-language safety signs, the thermal calculations for a roof in 50-degree heat. They do not see the 5,000 workers who built it all without a single fatal accident. They do not see the Islamic financing structure that made the funding possible. They do not see the backup generators waiting silently for a power failure that must never happen. They do not see the 15 years of engineering decisions that turned a patch of desert into the world's best airport development. They see a door, a beautiful door, and they walk through it toward a city that has welcomed travelers for 14 centuries. There is something profound in that. A building can be invisible precisely because it does its job perfectly. The columns hold, the roof breathes, the air stays cool, the bags arrive, the flights depart. And the pilgrim, who is saved for 20 years and traveled 10,000 kilometers, feels calm, feels ready, feels welcomed. That is the miracle of engineering done right. Not the tonnage, not the budget, not the awards. It is the feeling a person gets when they step off a plane in the city they have dreamed of their whole life. And the building around them says, "You are here, you are safe, you are welcome." Trees of steel stand in the desert and hold up the sky. Geometry drawn from centuries of Islamic art carries the weight of the world. And 5,000 hands built something that will receive millions of people for decades to come. If you found this story worth your time, subscribe to the channel. There are many more like it waiting for you. Every great structure has a story this deep. Every great structure was built by people this dedicated. Thank you for watching.